7. It's going to be using expressions to describe patterns, and that's exactly what we're going to do today. We're going to find missing numbers in patterns, and then once we find that missing number, we're going to write an expression to describe that pattern. So, let's go ahead and get started. So as we set the scene for today, you know how to write and evaluate algebraic expressions. That's what we've been working on this topic. So today what we're going to do is we're going to write algebraic expressions to describe patterns found in input-output tables. But before we can do that, we need to first do some vocabulary. So go ahead and flip to your vocabulary section, and we will define what an input-output table is. But before we even get to vocabulary, I almost forgot, we'll do the problem of the day. So I'm going to put that on the screen, and then flip to your vocabulary section, and we're going to define input-output table. I drew a chart on the board behind me. What I would like you to do now is in your PBIL section, copy this chart down. So you'll have to pause the video because then I'm going to jump into it here in just a few seconds. So I'm going to move aside, go ahead and copy this table down. So at the top there we have paper and pictures. Pictures is on the right, paper's on the left. And go ahead and fill that out accordingly. Here's the problem that we're going to get into using this table. We're going to pretend that a graphic artist was printing pictures. So how many of you have ever printed pictures? You know that you can print different sizes, different layouts. So what this graphic artist did was he printed pictures, and he's got different number of pictures for a piece of paper. So what we want to see is he's keeping track of how many pictures and how many pages he used. So he used the same number. If we can go through and find a pattern. So when he printed 6 pictures, he used 1 piece of paper. When he printed 30 pictures, he used 5 pieces of paper. When he printed 12 pictures, he uses 2 pieces of paper. So what we're going to do is we're going to see if we can find a pattern and then apply that to our input-output table. Looking at our input-output table, we can use it to try to find a pattern. Okay, so on an input-output, if you remember from your definition, the input's always on the left and the output's going to be on the right. In order to get from our input to our output, we're going to follow a rule. And that rule is just going to be an expression that we're going to write. So let's look and see. So for this problem, like we said, there's a graphic artist, and that graphic artist is printing the same number of pictures on a piece of paper. We're trying to figure out how many pieces of paper they're going to be using for however many pictures they need to print. So we're just going to solve this problem using an expression, this pattern, right? So what we know is that when we input 6, we're going to get an output of 1. When we input 30, we're going to get an output of 5. When we input 12, we're going to get an output of 2. So now we need to answer, if we're going to input 36, what's our output going to be? How many pieces of paper are they going to use? Well, we can solve this just by finding a simple pattern. So let's see. When we try to get 6 input, an output of 1, there's really kind of 2 rules that we could follow, or 2 options, if we're just looking at that first row. Option 1 would be maybe 6 minus 5. 6 minus 5 will get us to 1. So 6 minus 5. If we do 6, take away 5, we're going to end up with 1, right? Option 2 might be 6 divided by 6. And what this is saying is that we would take our input and divide it by 6. Or we're going to take our input and divide it by, and subtract 5 from that. So either one of these rules is going to work for that first row. But in order to find out if our expression or our rule is going to work for the whole input table, we need to check multiple rows. So let's look at the next row. 30 is going to be our input. So our input is no longer 6. Our input is 30. If we keep our same rule, though, that it's going to be minus 5, is 30 minus 5 going to equal 5? No. So option 1 no longer works. But let's check out option 2 and see what we can get. Option 2 is our input. Our input is no longer 6. Our input is now 30. And our rule stays the same, divide by 6, because we're testing this rule, we're testing the expression. So our input, 30, divided by 6. Well, what's 30 divided by 6? That's going to end up giving us 5. So option 2 works out for the next 2 rows. Let's check it on this 3rd row just to be safe. So remember, we're taking our input, and we said that our rule that we're going to test is divided by 6. So our input is 12. 12 divided by 6, is that going to give us 2? It is. So we now know what our rule is, what our expression is going to be. It's going to be, and we're just going to skip down to the bottom real quick. If we plug in x, x is our input, right? So it's going to be x divided by 6. X, remember, is a variable. And the variable tells us that we have an unknown value. So we could plug in any of these, and if we follow that same rule, divided by 6, it's going to give us the correct output. So to finish the table, if we take our newfound rule of x divided by 6, we can find the following 2 columns. So we're going to plug in x. This time the value for x is 36. 36 divided by 6, because our rule is going to stay the same. That's going to give us an output of 6. And for the final one, if we have our new input of 24, we're putting into our expression 24. Well, the output, what it's going to give us, what it gives out after the input, is going to be 24 divided by 6. That's going to equal 4. So if you see, when we're using input-output tables, we're just looking for a simple pattern. Once we find that pattern, we can create an expression for it, and that's going to make it a lot easier to solve for our inputs. So go ahead and flip to your guided practice. We'll do a few more problems, and then I'll set you loose on your quiz. To do a few practice problems, I'm going to flip this input-output table on its side, just to show you that they can look like different things. But as long as you know which one's your input, so in this one the top's the input and the bottom's the output, it's going to be the same thing. So don't let the format of it or the layout confuse you. So here's an input and an output. So our input is going to be x. Whatever we put in for x, okay? We need to find the rule that's going to get our input. We're going to put something into our rule that we're going to make, and we're going to end up getting an output. It's going to give us something. So if we put in 0, we get out 3. If we get in 1, then we get out 3. If we put 2 in, we're going to get 5, 3, 6, 4, 7. Well, just looking at this input-output table, it seems like there's a pattern already, right? If we look at the top, it's 0, 1, 2, 3, 4. If we just continue that pattern, we could probably solve for almost any number, right? So what if I said that we wanted to figure out what 8 is going to be? I want you to see if you can do that on your own. And once you've tried that on your own, then go ahead and follow it with me. So go ahead and pause here. See if you can tell me when we input 8, what's the output going to be? So go ahead and pause now and do that. So hopefully you paused and now we're back. If you didn't pause, that was a very long break, wasn't it? So if we continue our pattern up top with the input, we have 0, 1, 2, 3, 4. I'm just going to keep going down. 5, 6, 7, 8. So now I would continue my pattern on the bottom if I could find one. I have 3, 4, 5, 6, 7, 8, 9, 10, 11. So I continued my patterns across. I was able to find it, so I just plugged it in. So when I input 8, my output is 11. So when we input 8, our output's 11 on this. But I don't want to just do a pattern, because what if I had a number like 96? So what would I do if this was a bigger number in my input like 96? How would I find that expression? Well, we're going to do it the exact same way. We're going to find that rule just like we did in our problem before. So I'm going to take my first input and figure out how to get to my output. What would my options be? Well, I could take 0 plus 3, and that would give me 3. Or, well, that one's pretty simple, right? 0 plus 3. I can't do 0 times 3. That's going to be 0. I can't do 0 minus 3 or 0 minus a number. So let's just leave it at 0 plus 3 for right now. Let's look at the next one. If I did an input of 1, if I put in 1, what am I going to have to do to that 1 to get to 4? Well, if I kept that same rule of plus 3, 1 plus 3 is going to give me 4. That's the correct output. Let's do another one just to be safe. What if we picked over here 5 and 8? If I input a 5, and if I keep my same rule as plus 3, then that's going to give me 8. So that makes it true. So my rule for this input-output table is simply x plus 3. That's the expression we're going to use. So if we were going to use a bigger number like 96, and I did 96 plus 3, well, my output is just going to simply be 99. So an input-output table, you're just looking for a pattern to create an expression, and from there, you're good to go. So go ahead and take your quiz, see how you do, enjoy your weekend, and I will see you on Monday in class. Okay, and so here are the